Hello, my name is Caroline Reynolds. Today I am stepping in for your usual TV6 broadcaster, and we're going to actually talk about something important, physics, and how it relates to swimming. Alright, so today I got some help from three of my friends who happen to be UP Championship swimmers. This is Nathan Rotundo, Janelle Carroll, and Logan Veer. Alright, so Newton's first law of motion states that an object in motion stays in motion until acted upon by an outside force, and an object at rest stays at rest until acted upon by an outside force. Newton's first law explains why it takes extra force to get moving or to stop moving through two different forces. These are static force and dynamic force. For the static force, it basically states that a body at rest wants to stay at rest, and it must overcome this before you can start fluid movement. You will notice this when you push off the wall or the bottom of the pool, like Janelle here. The drag you feel when the movement starts is the static force that you overcome. And in swimming, we feel this every single day on every single flip turn off every single wall. So this dynamic force is kind of that your body in motion wants to stay in motion. And it's kind of why swimming becomes fluid once you start moving. But eventually drag pulls you to a slowing stop if you don't continue to move your arms and legs. So now, Newton's second law of motion states that the change of motion depends on the magnitude of the force and the mass of the object. This second law explains why some people can swim faster than others. For example, if two people have the same mass and pushed off a wall and did not take any strokes, the person who used the most force pushing off the wall goes farther. Acceleration in this case was greater for the person who produced the greater force because the masses were equal to each other. Take the same two people and have them race to the other side of the pool. The person who wins the race would have to create more force the whole time in order to maintain the lead. Newton's third law of motion states for every action there's an equal and opposite reaction. And Newton is describing exactly how movement occurs when discussing the third law of motion. For example, when you pull the water down your side using the breaststroke, the water moves down your feet when you are propelled forward. Action in this case would be you pushing your arm in the water, and the equal reaction is the water pushing back on you. Opposite reaction is the reason that forward movement occurs.
Physics is cool!